Okay, it's time to prepare for exam number 3. Exam number 3 is scheduled if you're in section 1, which is the Monday, Wednesday, Friday section. Exam number 3 is scheduled for Friday, April the 24th. If you're in the Tuesday, Thursday section, that's section 4, exam number 3 is scheduled for Thursday, April the 23rd. In both cases, whether you take the exam on Friday or you take it on Thursday, the exam will become available to you at 11 a.m. on Blackboard. This is the regular class time, Monday, Wednesday, Friday, and Tuesday, Thursday, and it will become available on Blackboard at that time. And there will be a 120-minute time limit on the exam. Normally, I would expect you to do an exam like this in 50 minutes, but since we have to deal with Blackboard and there may be some other things that delay your responses a bit, we'll set the time limit to 120 minutes. So once you begin the exam, you've got 120 minutes to complete the exam. The exam must be completed in one setting. So once you begin, you cannot quit and start again. You have to arrange your schedule so that you can sit down and take the exam in one setting. As you take the exam, once a question is completed, it cannot be revisited. So when you've completed your answer to a question and you've clicked the key to continue to the next question, you have locked in your answer and you cannot go back and revisit that question. Some of the questions on the exam will be multiple choice. I presume you'll be able to work your way through those pretty easily. You just pick the choice, your response that you prefer, and make sure that you've settled in on the answer you like, and then click to continue to the next question. Those will be easy for you to complete. Some questions will require a one-sentence response. You should be able to answer the question in one sentence. So you simply go to the response window and type in whatever you wish as a response to the question. Some questions will require you to write C++ code in the response window. So again, you will be able to go to the response window, and I expect you will just simply type in the C++ code that you wish in response to the question. And don't worry too much about it. It just needs to be the text sequence that you would like to respond with in the form of C++ code, and make it as accurate code as you can. It is not proper to open a compiler and actually try to run and test the program. I don't expect you to do that. I expect you to go straight to the window and type in the C++ code as if you were typing it into the compiler. But I do not want you to open the compiler when you're taking this exam. Some questions will require you to create a table in the response window. Now, you may not have created a table in Blackboard before, so I've put together a quiz for you to work through, and there's nothing to it except to go through it and practice typing C++ code in the response window. And it doesn't matter what you type. It's just for you to have some practice writing something more than a single sentence in the response window. And another question requires you to or asks you to create a table in the response window and to fill out the table, there's a tool in the Blackboard toolbar that will allow you to insert a table into the window, and then you have to go back in and put and enter letters and numbers or whatever you wish into each one of the cells of the table. So this quiz will give you an opportunity to practice that before the day of the exam. There is also some other tools like how to put additional rows into your table, how to delete rows, or if you wish, or columns, or how to put additional columns in your table. Then you should probably play with the table. You can click on it and grab its handles on the sides and on the corners, and you can resize the table to make it more useful looking to you. So this announcement quiz is just for you to practice those responses. Okay, the material on the exam, we will have at our disposal all of the material on exam 1 and all of the material on exam 2. Since exam 2, you've spent more time with arrays and pointers, and I encourage you to go back and look up the connection between arrays and pointers, and be familiar with that, and then also strings. So these 4 topics are more or less the new material since exam 2, so you can expect questions over this new material as well. If you look at the programming exercises that you've completed since exam number 2, exercise 23 had you input values into a string using the console input command, and it manipulated strings and ASCII characters. Exercise number 24 had you input data from an external text file and manipulate that data. And these, with the histogram and the sorting, these again are array operations. So you should be able to write programs that perform operations on arrays. And then you also output the data to an external text file as well. Exercise 25 dealt with pointers, specifically pointing to integer values. Exercise 26 dealt with pointers pointing to type double values. So you should be familiar with the how to declare a pointer, how to assign an address location to the data member of a pointer, and how to use the asterisk operator as the contents of operator to reassign values to memory locations through the pointer. So that's exercise 25, 26, and 27. This is the basic concepts of a pointer, and how to declare them, how to use them to assign values to memory locations. Exercise 28 was an iterative calculation. Exercise 29 was recursive function calls. Those are pretty straightforward programs for you to write, I hope. Exercise 30 was a bit more involved. It explained Gaussian elimination, and then the solution to this problem was given to you in pseudocode. It was a matter of translating the pseudocode into proper C++. And exercise 31 is where you read in a text file, and then based on the number of characters in the file, you either came up with a code to encode it into some kind of secret code, or you came up with the decoding algorithm to decode it into readable English. but that involved manipulating strings and working through strings as an array of characters and ASCII code values, and how to use the numerical ASCII code values to manipulate characters. If there's a question about that requires an ASCII code value on the exam, I will give you a table with the ASCII code values. So you don't necessarily have to have a source for those code values at your fingertips. If you need that information for the exam, I will give that information to you. Allow me to go over the solution to exam 2, because I think it will be helpful for you to see what I'm looking for more explicitly when you do exam number 3. This is the solution for section 4. Section 1 has a slightly different exam, but I think in section 1 you can follow along and you'll be able to see what I'm looking for with these questions. Circumstances have prevented me from returning your tests to you. So you probably don't remember what was on these exams, but nonetheless, I want to go over this solution. Problem 1 was a matching question where you had to match the C++ statements in column 1 with the appropriate description in column 2. I will post the solutions to Blackboard so you can see these the 2 documents for both section 1 and section 2, and you'll be able to figure out how they should match up. Most people got most of these correct. If people sometimes missed 1 or 2 or 3, so you should be able to figure out how those matching statements should be lined up. Okay, problem 2 asks you to first write a function with the name parallel. So I was looking for a function with the name parallel. So that was the first thing I was looking for in your response. That will calculate the equivalent of 2 parallel resistors by the following equation. Then here is an equation I want you to put inside the function. R1 and R2 in these equations are the 2 type double parameters. So I was looking for 2 type double parameters in the function named R1 and the other named R2 that are to be passed to the function by value. So you'll notice that we're passing just the value of R1 and just the value of R2. We don't have any addresses in here. R equivalent, that's the result of this equation, is the type double value that is to be returned by the function. So that is here the type double value that is returned. So the way I've written the question, I was looking for this kind of C++ statement, return type double, that satisfies this requirement in the question. Function name parallel, that satisfies this requirement, and the parameters are a 2 type doubles that satisfies this requirement, and they are by value, so that satisfies the other requirement by value. Okay, so this the first line is required to satisfy all of those requirements. And the function can be written out in a single line. If you wrote the function out in more than 1 line, that's perfectly fine. But this is the minimum that I think fits the requirements. It performs this calculation with this this part of the statement, and then it returns that value to the function call. Okay, the next part of the question is to write a main function Here it is. Write a main function that will do the function call. Okay, so here's the main function. And all I want this function to do is to perform the function call, but the function call returns a value, so it has to return the value to something. And so in this case, I chose to declare a variable that I called R equivalent, and then assign that the value. And here is the function call parallel. See, this function call parallel is a function call back to the function that I just wrote called parallel, and it's sending it two parameters by value. And the easiest way is just to send these literal values. I made sure they were type double, so that so it would match the parameter type. So those two values are sent to the function. It performs the function, and then it returns the value to the function call, which is then assigned. And that is a sufficient function, or a main function, to fit the requirement for the question. Problem 3 asks you to trace the operation of the program line by line. It's not asking you to interpret the statement on each line. It's asking you to go line by line and determine the sequence of operation, tracing the operation line by line, the sequence in which the lines of code are executed, and begin with the execution with line 7. So here in this table, it starts with line 7. Looking at the program, line 1 is a function f, returns an integer, takes a type double a and an integer b, so it takes a double, then an integer, and then line 2 is the definition of that function. Line 3 is a function f, so it shares the same name, but they can be distinguished by the parameter list. In line 1, function f takes a double and an integer. Line 3, function f takes an integer and an integer. And then line 4 defines the operation. Then line 5 is another function with the same name f, but it takes an integer and a double. Well, that's different than taking a double and an integer. So line 5 and line 1 are different functions because their parameter lists, the order is different. And that does make a difference. And then line 6 defines the operation of that function. And then we get to line 7, which is the main function. So tracing the operation line by line, first line 7 is executed, and I just wrote main function because that's what's on line 7. After line 7 is executed, we go to line 8. Line 8 is a function call using an integer and an integer, and that makes a difference because this is a function call back to the function on line 3. So the line following line 8 is line 3. We're doing function f, and it assigns the value of 2 to the local variable a, and it assigns the value of 4 to the local variable b. After the function call on line 3, the next line to be executed is line 4. So line 4 takes the value for a, which was 2, turns it into a double, so this is 2.0, divided by, it takes the value of b, which is 4, and turns it into a double, 4.0. So we have 2.0 divided by 4.0 is 0.5. That's a type double, which is returned as a type double. So that completes the function call in line 4. That returned completes the function call, and that is returned now to the function call in line 8. So the line that is executed after line 4 is line 8. So we go to line 8 in the code, and it does a console output, and 0.5 appears on the monitor. The line executed after line 8 is line 9. And line 9 is a function call. But this time, notice that the function call is an integer followed by a type double. So the integer followed by a type double is a function call back to line 5. So the line following the execution of line 9, it then goes back to line 5. So after line 9 is executed, we go to line 5. The program is executing line 5, this function call. When this function is called, the value of the integer value of 2 is assigned to variable A, and the double value 2.2 is assigned to B. So A is assigned the value of 2, B is assigned the value of 2.2. The next line to be executed is line 6, and inside line 6 it turns A from 2 into a type double, so it turns it from 2 to 2.0, and then it multiplies by the value of B, so you have 2.0 times 2.2, that's 4.4, and then that value is 4.4 is returned back to the function call in line 9. So the line that follows line 6, after line 6 is executed, the next line is line 9. It does a console out, and 4.4 is printed on the monitor. After line 9 is executed, the next line is line 10. And line 10 does a function call with a type double followed by a type integer. So those parameters make this a function call back to the function in line 1. So after line 10 is executed, the next line is line 1. 2.2 is assigned to the local variable A as a type double, and 2 is assigned to the local variable B as an integer. Then after line 1 is executed, line 2 is executed, and what it does, it takes the value for A, which is the double 2.2, and it multiplies by the integer B. Now, when C++ does this, it promotes B to a type double, so it's 2.2 times 2.0, and that would be 4.4. However, that result is turned into an integer in this function, so the integer value from 2.2 times 2 is just 4. Then this value of 4 as an integer, as this integer return value, is returned back to the function called in line 10, and it completes line 10 by printing on the monitor the value of 4. And that's the end of this program. Okay, but the point is, when tracing the operation of the program line by line, the point is to see if you know which sequence the lines are operating in. If that's a mystery to you, then you really, I'm not sure that you know C++ well enough. Problem 4 asks you to evaluate the summation with a main function. This is a summation that gives accumulates a sum called S. So the main function I wrote, as always, when you evaluate a sum, you have to initialize the value of the sum to 0. This line, by the way, needs a semicolon to be complete. So the first line in the main function sets the value of S to 0. That's going to be the variable where I accumulate the sum. And the summation is carried out in a for loop. So I set up a for loop using the loop. The index for the summation is n, so I use the same variable n as the loop control variable, setting it initially equal to 0 just as it is in the summation. And then the condition for the loop is n less than 10, so it will do the summation n equals 0 up to 9, and then n is incremented. Inside the loop, the sum is accumulated by taking the old value of s and adding the next term in the series and then assigning that back to be the new value of s. So the first time through, s is equal to 0, n is equal to 0. It takes the old value of s, 0 plus then 1 over, and then we have a 0 plus 1 times a 0 plus 1. So that's going to end up to be 0 plus 1 is evaluated to a 1, and that becomes the new value of s. And then n is incremented, and the next time through the loop, the new value of s is equal to the old value plus the next term in the sum. And this is continued through each iteration of the loop until we've gone through the entire range of the summation. And that will give us a value of s, which is the value of this sum. I didn't do anything with the accumulated value for s in this case, but this is the minimum amount of code that will evaluate this sum. Problem 5 is another trace the operation question. So trace the execution of the following code fragment line by line again. So it's not interpreting what each line does, it is tracing the operation and determining which line of code follows which line of code. And fill in the tables. So the program, well, let's look at the table first. We're starting off with line number 1. We have in these 3 columns the variables a, b, and n. So in line 1, integer a is declared, but it doesn't have a value yet, so I put a little tick mark there just to indicate that I knew it was declared. The line that follows line 1 is line 2, declares integer b and assigns the value to 0. So here integer b has a value of 0. Line 3 is a do statement, so this is a do loop, and then it performs all of these statements inside this set of braces. And also in line 3, the first, it establishes a value of 0 for a. So a is given a value of 0. And then it goes to line 4. Line 4, the number 4, is an FOR, a for loop, which first declares the integer n and sets it equal to 0. So integer n now has a value of 0. The conditions for the loop, n less than 2, 0 is certainly less than 2, and then we increment n. And then the equation, the loop itself is between the end of this closing parentheses and this one line of code out to this out to the semicolon. So that is a equals a plus n, b plus n is everything that is in the loop. That's all that the loop contains. If we had more than one line of code, we would put it inside the curly braces, but that's just that single one line of code. And what we take the value of a. So we're doing line 4, so the value of a is a 0, so I wrote a 0 there. Then we look at the value of b. The value of b is a 0, and a 0 there, and then the value of n is a 0 right there. 0 plus 0 plus 0 is assigned to the value of a, so a remains a 0. And that then that's the end of the loop. So we increment n. So we're still operating on line 4 because we're inside the loop. N now is equal to 1. So we do the loop calculation again. So let me see. So it takes the value of a, and a has a value of 0 at the moment, a value of 0. and then we add the value of b, which is also 0, and then we add the value of n, which is a 1. So we have 0 plus 1, and that's assigned back to a. So now a has a value of 1. And that is the second time through the loop. So it goes back and it increments the value of n. Well, that would increment the value to 2. 2 is not less than 2, so that stops the evaluation of the loop. And then it goes to the next line, which is line 5. And in line 5, b is equal to b plus 1. So we take the previous value of b, which was a 0, add 1, and that's assigned to the new value of b. So now b is equal to 1. And that's the 3 statements in the do loop. And then we hit the while statement, so it checks the condition b less than or equal to 2, and b is equal to 1, and 1 is certainly less than 2, so that is true. So since that condition is true, the next statement is goes back to line 3. So line 6 in the program is followed by line 3, and let's see, we'll pick up line 3 in the next slide. We're looking at the execution of line 3. This is the second time, and what happens is a is assigned the value of 0 in line 3, and then line 4 again starts the for loop. N is reset to 0, so n is reset to 0. Actually, I think technically, when the loop is completed, the variable n goes out of existence until the next time the loop is created. So really, I shouldn't have anything in the table after it's broken out of the loop for the value of n. But nonetheless, when line 4 is again executed, n is reestablished and set equal to 0. And it does this calculation. It takes the value of a, which has just reset back to 0, plus the value of b, which now b has a value of 1, plus n, which has a value of 0. 0 plus 1 plus 0 is a 1. That's assigned to the value of a. And then it does the loop a second time by incrementing n to a value of 1. In this case, a is equal to the old value of a, which was 1, plus the value of b, which is also 1, plus the value of n, which is 1. 1 plus 1 plus 1 is 3. 3 is assigned to the value of a. That's the end of the for loop. Then it goes to line 5. b is equal to b plus 1. The old value of b is 1. 1 plus 1 is 2. So line 5 assigns the value of 2 to the variable b. Then line 6, the loop condition again, is 2 less than or equal to 2 is certainly true. Since that's true, the next line of code again is back to line 3. So line 6 is followed by line 3. A is reset to 0. Then that's followed by line 4, where n is reset to 0. And then we have a equals a plus b plus n. So a is equal to 0, b is equal to 2, and n is equal to 0. 0 plus 2 plus 0 is 2, so that's assigned to the value of a. And then the loop causes n to be incremented, and now we're adding a, which is equal to 2, plus b, which is equal to 2, plus n, which is equal to 1. 2 plus 2 plus 1 is 5. That's assigned to the value of a. And that's the end of the for loop. Next is line 5. b is equal to b plus 1. So b is equal to the old value of 2 plus 1, and makes b equal to 3. And then it does line 6. And 3 checks to see if 3 is less than or equal to 2. and that returns a false, and that's then it would continue on to line. There is no line 7. That's the end of the program. Okay, so this is the execution of this program step by step. Again, it's not an interpretation of each line of code. It is tracing the executions, so to determine which lines are executed and the order in which they are executed, with the additional information of how these variables are updated every time or regularly. A new value is written to the variable, so this helps to keep track of those values.